Let's take a look at these questions. A reaction is most likely to occur when the reacting particles collide with proper orientation and proper A. Charge, B. Energy, C. Mass, D. Volume. A reaction is most likely to occur when the particles have orientation and proper and enough energy. So answer is B. That's just something that we ought to remember. Question 1.6. Catalysts can increase the rate of a chemical reaction by providing an alternate pathway with higher activation energy, the same pathway with higher activation energy, alternate pathway with lower activation energy, or the same pathway with a lower activation energy. We can answer this by just thinking about the potential energy graph. That's a reaction without a catalyst. Then the dotted line would be one with a catalyst. The first thing that a catalyst is going to do is that it is going to reduce the activation energy. And the second, you can think of it, is it's providing an alternate pathway for the reaction. So the answer for this question is going to be C. Let's take a look at the long questions. Graph B represents the Maxwell Boltzmann energy distribution curve for reaction mixture at 300 degrees Celsius. So this is our original. Okay. Area X represents the number of molecules in the mixture that have enough kinetic energy for the reaction to take place. So area X, let's highlight that in, let's go with this color. Okay. Next, we've been given the graph, and the question says, give a term for the minimum energy required or needed for a reaction to take place. That is called the activation energy. So 5.1 is activation energy. It's just a definition that we need to learn. Question 5.2. The temperature of the mixture is now increased to 500 degrees Celsius. Which one of the graphs, A or C, represents the distribution curve or the distribution curve of the mixtures at this higher temperature? So what happens if you increase the temperature? So if you increase the temperature, more particles have greater kinetic energy. So you have an increased EK. Now, if we examine the graph for B, that is, you can see that most of the molecules fall in this region. So most of the molecules will have a kinetic energy somewhere here. But if we increase the temperature, the kinetic energy should shift more down the x-axis. And so what we should be focusing on is this graph right here in blue, because this one represents an increase in the kinetic energy. So from here to there, and that will correspond with graph C. So C is the answer. And 5.2.2, give a reason for the answer. It's that more molecules have an increased kinetic energy. 5.2.2, more molecules have an increased kinetic energy. Okay? Now, an easy way to remember it is if you just learn the curves. So if this is your original curve and you are increasing the temperature, this one is an increased temperature, you should be looking for two things. The first is that the peak is going to shift to the right, as seen in this question from B to C. And the second is that it's going to shift downward. So if there's an increased temperature, you'll find that the curve will probably look something like that. So it'll go down and it'll shift to the right. And if you decrease the temperature, it's going to be the opposite. Okay. Question 5.2.3. Use collision theory to explain how this increase in temperature will influence the rate of the reaction. Okay, so if we increase the temperature, remember that affects the kinetic energy. So that's going to increase the kinetic energy of the molecules. That's going to have an increase in the number of effective collisions per unit time. And that's going to increase the rate. Okay, question 5.3. A catalyst is added to the mixture. 5.3.1, what is a catalyst? A catalyst is a substance that is added to speed up a reaction without being used up. Question 5.3.2, how will the above mentioned action, so the use of a catalyst, affect the size of the area X? So the area that we've highlighted here in this orange color. Write down increase, decrease, or remain the same. So how does a catalyst affect our graph? So if we use a catalyst, let's say this is my original graph. A catalyst doesn't affect the shape of the graph. Rather, a catalyst decreases the activation energy. So the activation energy line would move to the left. So this is the activation energy with a catalyst. Now recall earlier, area X represents the number of molecules that have enough kinetic energy. So if a catalyst decreases that activation energy, the number of molecules was this amount, and now the number of molecules is going to be this whole amount here. So adding a catalyst will increase the area. And explain your answer, we've already done so. Okay, that's it. Thanks for watching, everyone. Hope you found this useful. I'll see you in the next video. Bye-bye.